to start off by going over venting and then move into a little bit about troubleshooting. So with the venting, obviously use the right material for the job. Stainless steel is an approved material, as is PVC, CPVC, or polypropylene. Depending on the jurisdiction you live in, PVC sometimes can give you headaches, so check to make sure that CPVC or polypropylene is not required before you vent your boiler. And where possible, I would recommend sticking with the CPVC or the polypropylene. They do tend to stand up a little bit better over time, and you're less likely to have a concern or a problem with them. When you're doing your venting, we don't often think about this, but if you use lots of solvent and cement, you're going to get a buildup of vapors in the venting material. And of course, those can be very highly flammable. So there is a mandatory pre-commissioning procedure in our manuals. This basically advises you to allow the boiler to run for a little bit with no gas and the spark disconnected so that you can vent any of these gases out. It really only applies if you're installing the boiler the same day and then trying to run it. If you've done the venting for the boiler the day before, this should be fine. Follow the vent lengths that come with the boiler that you're working on. As a rule, most of the NTI boiler line is going to count an elbow or 45 as 5 feet of equivalent venting. Check the size requirements. Depending on the model, you can get a mixture of sizes. Sometimes you can extend the vent length if you go with a different size. We have boiler models which will range with venting anywhere from 35 up to 150 equivalent feet of venting. So vent terminations, your standard vent termination is an intake facing straight down with an exhaust 18 inches above it facing perpendicular to the building. You can achieve this separation by either bringing the intake down or the exhaust up, as long as the orientation of the two parts to each other is the same. With each of the boilers, these 3 elbows on the outside do not count. Now, that's not universal, but most of the products are done that way. So keep an eye on that, depending on the boiler you're working on. You're going to get bird screens with every boiler. Make sure to use these. These not only keep out small animals, they also keep out matchbox cars. They keep out small animals, golf balls, rocks. One unfortunate case, somebody stuffed a hose down the intake pipe and turned it on. So use the vent screens. They do provide some reassurance that hopefully nothing too bad will happen. When you're doing your vent terminations, you want to make sure that you're maintaining your distance to doors and windows. So in Canada, the minimum required separation between an exhaust and a window that opens is 36 inches. Where possible, I would recommend more than that because you can get a very large plume of gases coming off the exhaust, and in the winter, not only does it not look particularly good, you can actually get complaints about gas smells, even if you follow these requirements, because some of that flue gas can make its way back into the building. We do have minimum clearances available. Now, these are minimums. You are allowed to go more, and I would recommend where possible that you do so. So when it comes to the separation between the intake and exhaust, 18 inches is the smallest we can allow you to go. This is one of those cases where going that extra mile and giving us an extra 6 inches or an extra foot is actually going to help you and make it less likely for flue gas cross-contamination to occur. So sometimes the minimum clearances are there to be exceeded. So your distance to a window, 36 inches is as close as you can go. We'd recommend more if you can get it. Same with the snow allowance. New Brunswick has 19 inches worth of snow allowance. So we're not allowed to vent the intake more than 31 inches above the ground. There's a horizontal separation when you're using this kind of termination. So we would recommend 4 inches center to center. And that's actually the preferred or the best practice is to keep that horizontal separation fairly small. You are allowed to go up to 12 inches horizontally with this type of termination. But the further apart you go horizontally, within reason, it actually promotes flue gas recycling. So keeping them close together with a large vertical separation is the best practice. When you're doing 2-pipe roof terminations, the same rules apply. 18 inches of separation vertically at a minimum, 12 inches plus snow grade for your air inlet, and your exhaust should face perpendicular to the peak of the roof or any surface. So if you've got anything up there that could be damaged by flue gases, you want to blow away from that. You can also use concentrics up on the roof. Follow the guidelines that come with the concentric kit. They have special requirements depending on the kit you use. All of them have been engineered to work a certain way, so follow the directions that come with the kit you buy. On the right here, you've got an optional exhaust, which is blowing straight up and out. And where possible, this is the termination I would do, is to blow your exhaust straight up rather than exhaust option 1. And the reason for that is it's the best way to get the flue gases away from the air inlet. If you're dealing with a peaked roof, if you're terminating the exhaust below the peak of the roof, it may be advisable to blow it away using the elbow and to blow it away from the peak of the roof. If your exhaust is on a flat roof or if it's level or nearly level with the peak of the roof, then generally straight up is probably going to provide you better flue gas clearance than blowing horizontally. Exterior venting, you're allowed to do this obviously up to 20 equivalent feet. Make sure you support it adequately. The only real thing that I would change when you're doing exterior venting, all the other rules apply. Normally we would require a 1/4 inch per foot of slope. Anytime you do exterior or venting through unheated spaces, I would recommend a 1/2 inch per foot of slope. And the idea is to get the condensate that forms in that cold piping out of there faster. We don't run into any risk of freezing. I've yet to see an exhaust vent freeze over as long as the boiler's operating. So far that hasn't been a concern when it comes to insulating. We can't advise that you do that. If you do want to insulate your exhaust venting, check with your local authority that has jurisdiction. If you decide to use a chimney as a chaseway for your exhaust vent, that's perfectly fine. Please disable whatever was previously using the chimney and make sure that you're not running that at the same time. To date, I've only had that phone call once, but it was an interesting phone call to find out the wood fireplace and the boiler were sharing the same chimney in some fashion, and the results are sort of what you might expect. So make sure the chimney's vacant. Line it with an approved material, so you can't just dump flue gas directly into an old chimney. You have to line it with the approved material. And if you're chasing your air intake through that chimney, again, that's no problem as well. Just cap off the top of the chimney, make sure your clearances are correct, and you're good to go. When you're getting your slope on your exhaust, whether it's a 1/2 or a 1/4 inch per foot, I'd recommend you always use the swing joint, which is the 2 elbows side by side. This allows you to set your pitch without putting any strain on the vertical of the boiler. If you do put strain on the top of the boiler, you can get premature flue gasket failures, causing leaks and damage to the boiler. And all of this is designed to avoid cross-contamination. So the one contaminant, so when you're doing any sort of boiler venting, you want to make sure that you're avoiding contaminants. And the one that we can guarantee is on every job site is the flue gas from the boiler itself. If the boiler's sucking in flue gases, it's going to potentially frost over the intake, which is in a lot of ways a fairly moderate or minor concern. If this happens once or twice, it probably won't damage the boiler in and of itself. It will shut it down and create a service call. Where the real damage comes from is over a longer period of time, several years, continual low-grade flue gas recycling will start to damage the interior of the boiler quite significantly. So this was a job site in Halifax, Nova Scotia, multiple boilers, and there's a couple of things wrong here that I'd like to point out. So obviously the 2-pipe termination is done incorrectly. The intake should be straight down. 45 is not the end of the world on its own, but the exhaust that is 45 down is really kind of a problem. That's not allowing flue gas to clear as well as it could. The other thing to look at is these square stainless steel exhaust terminations are an older vent kit that we don't sell anymore. The problem is, though, that they're placed too close together horizontally. So when you're doing multiple boilers on the same wall, each boiler can cross-contaminate with the boiler beside it, And in Canada, at least, the minimum acceptable clearance from the intake of one boiler to the exhaust of another is 3 feet. So that 3-foot guideline wasn't met. But even if it had been, with this many boilers venting into this space, there's a good chance you could still get some cross-contamination issues. So ideally, what you'd want to do is stagger these in a way that will use up the least amount of space on the wall, while also creating the least chance for flue gas cross-contamination. And the way I would recommend doing multiple vents, where possible, is you'd bring out your intake, then your exhaust, your intake, then your exhaust, your intake, then your exhaust for each of the boilers. And you'd sort of put them in a row fairly close together horizontally with very little separation horizontally. And then make all of your separation, your 3-foot, do it all on the vertical. So you'd have your 3 intakes, a minimum 3 feet above your 3 air inlets, and then your 3 air inlets all down below facing straight down. So you'd probably only end up using 2 or 3 feet of wall space and on the horizontal, and then you'd be using 3-foot vertical instead of this application, and you'd be much less likely to cross-contaminate and save yourself a whole bunch of headaches. So just a brief video of obviously what not to do. So it's too close to an inside corner. Inside corners are a problem because it creates a situation where flue gas will often curl around and get drawn back towards the building. Too close to a window. This particular one is too close to an AC condensing unit and a window that's right below it. So a couple of problems. Obviously, you're going to get flue gas recycling in this situation. And also pay attention to where these flue gases are directed. Although blowing flue gas on top of an AC condensing unit is not really going to affect the boiler in any fashion, the homeowner won't thank you if their air conditioner dies a few years later because it's been dissolved by acidic flue gases. If you're dealing with stucco like this, you want to make sure that flue gases are able to clear the area. Because flue gas, unfortunately, is corrosive, it will attack masonry and destroy the stucco. It can destroy the walkway underneath it. Dripping on the walkway in the winters, that could be slippery and have slip and fall hazard. So just things to consider when you're doing your vent. Bunch of things here not to do. So we've got exhausts in the wrong location, too close to intakes. The one that I want to point out more than anything is underneath a vented soffit. So the minimum required clearance under a soffit is typically 2 feet. If it's a vented soffit, it's more than that. Now, there are a couple of options you have if you have to come out below a soffit. One of them is to potentially extend the venting to the exterior of the building, so to the far edge of the soffit, so that you're not under it at all. If it's a vented soffit, that's probably not going to be good enough because a vented soffit has the option to have flue gases get drawn into the attic space. We have seen instances of that where flue gas gets into the attic, it rots out the attic, and causes mold problems. So if it's a vented soffit, you can block that off within 6 feet either direction of the exhaust termination. That's one option. A better option is to bring the venting somewhere else that's not going to interfere with the soffit at all. This was sort of a creative solution to a poor venting job, so it's too close to an inside corner. Flue gas recycling was a real problem for this job. The other problem was the directions for the concentric vents weren't properly followed, and they're too far away from the wall. So when you put these concentric vents too far out from the wall, it actually promotes flue gas recycling. So there's a couple of things wrong here. The vertical separation now is okay. The horizontal was actually okay as installed, except for the fact that the kits were positioned too far out of the wall and they're too close to an inside corner. So again, inside corners minimum is 3 feet and preferably more depending on the size and shape of the corner. Having outdoor sensors in close proximity to your exhaust is not a great idea either because they can actually sort of see the extra heat sometimes, and that can cause them to give bad readings to the boiler, causing you headaches there. But the main concern here was just too close to an inside corner, and the 2 vents themselves were improperly installed, promoting flue gas recirculation. You'll notice that the clamps used to support the exhaust they're rusting quite badly. The flue gas, again, it is very acidic. If you use galvanized steel, if you use regular steel, if you use just about anything other than some sort of plastic or decent grade of stainless, it's going to get dissolved by the flue gases fairly quickly, and it will rust fairly quickly. And not only does it look terrible, it may not function for more than a few years before it breaks and doesn't do its job anymore. So anything you attach venting with, make sure it's a good grade of stainless or use some sort of polyethylene, PVC, generally plastic type of pipe holder. Otherwise, you end up with ugly, rusty looking stains like this. So this is sort of everything not to do in one picture. Exhaust too close to mechanical air inlets, temperature sensors right next to exhausts, intakes facing wildly off to the wrong direction, and it's all done above a gas meter. So this is just sort of an entertaining one for what not to do. So you really don't want to do any of this. I don't know whose job this was, but don't do that. If you're getting flue gas recycling, you're going to see damage to the venturi of the boiler. And the way that's going to evidence itself is the innards of the venturi are a nice black shiny plastic. It will turn into a not so nice dull plastic if it's recycling flue gases. So two ways you can recycle flue gases is one is you can suck the exhaust back in through the intake. The other way you get flue gas into a venturi is your post purge on the boiler is not long enough. So the reason it might not be long enough is you have unbalanced venting, so you're doing a north and a south wall. Maybe you're doing indoor combustion air, something like that. And what will happen is when the venting's not balanced, the intake might end up under a slightly higher pressure than the exhaust. And if you're doing indoor combustion air, what actually happens is the intake is almost always under slightly negative pressure because buildings are under negative pressure. And what will happen is any remaining flue gases in that exhaust vent will actually get drawn back into the building. And we'll talk a little bit more about indoor air in a second. If you're doing just generally unbalanced venting, that pressure differential across the intake and exhaust can actually force flue gases backwards through the system. The hot, moist flue gas will condense down on the cold air inlet components. It damages them through the act of corrosion, in addition to just get everything wet, which causes issues with flame proving, igniters not working, burners getting destroyed, that kind of thing. So when you're doing indoor combustion air, as a rule, I would say where possible, don't do it. It's usually your first and worst option. That's not always true, but for the most part, indoor air is 5 times more polluted than outdoor air. You're going to get potentially cigarette smoke. You're going to get different chemicals from paints, cleaners, solvents. You're going to get leftovers from kitchen cooking. So you're going to get oils and greases floating around. In addition to just all the other normal dust and dirt that gets into houses. On average, it means that indoor air, unfortunately, is 5 times more polluted than the air outside. Sources of things that you're going to want to watch out for when you're venting outside or indoors. Any sort of chemical fertilizers, herbicides, pesticides. Oddly enough, even the organic, as in manure type herbicides or fertilizers, can be just about as bad as the chemical ones. And a lot of that has to do with, and this is more for pig farms, but there's an ammonia compound that you get in manure. Gives it that acrid kind of smell. You burn that in a boiler, it actually does quite a bit of harm to the steel of the boiler. You want to watch out for cleaning chemicals, especially anything with chlorides in it. So Clorox is Clorox bleach. Bleach has chlorine in it. That's going to be a problem. You're going to get things like laundry detergents. Again, lots of chlorides in these. I didn't realize it, but I actually asked a water treatment company once about bottles for sending in water samples, and they advised me against using things like laundry detergent bottles because they actually use salt as a thickener, which for whatever reason, and apparently that can contaminate your water samples. So, and again, salt inside the boiler is quite bad, so most cleaners are a problem. Hair salons, watch out for these. There's all sorts of hairsprays. There's permanent wave solutions for those of you that are been around since the 80s or a little bit longer. Dry cleaners, obviously, a problem. You can smell them when you're driving by. Whatever that is, it's bad for boilers. Snow and ice melters, not something you'd expect to find inside a boiler, but we do find it from time to time. And that's because a lot of these vents are done over top of a driveway or a pad of some sort. And of course, those are kept salted and some of that dust gets sucked in. You mix it with a little bit of water or condensate and it starts to rot the combustion chamber out inside. Pool chemicals, again, chlorides, chlorine, it's bad. Paint and body sprays, there can be all sorts of problems with these. Again, try and avoid them. Big one, fabric softeners. So a lot of these dryer sheets now have fabric softeners sort of built into them, I guess. And when that's all vented outdoors, now you've got a very large area that's contaminated with fabric softener while the dryer is running. Most residential applications, you're going to find a dryer. And you're venting anywhere within 6 or 8 feet of it. There's a good chance that you'll be drawing in enough of this fabric softener material or gas that can damage the boiler. In addition, over the years, we've seen a number of boilers stuffed to the gills with lint, and they don't run particularly well on dryer lint. So indoor combustion air, again, laundry rooms, bad idea. Older buildings with exposed joist work like this, generally a bad idea. So keep an eye out for that. If you're doing a garage shop, again, this would be a terrible place to draw air from the boiler. You sawdust, obviously, in addition to all the other sort of dirt and junk that's laying around here. This will cause dust to get into the air. The dust gets sucked into the boiler, and depending whatever chemicals are stored around here, that will all combine to create potentially damaging circumstances for the boiler. So now this was a job where the indoor air was actually drawn from a vacant chimney. So what was done here was the exhaust was chased. So they used the chimney to chase the PVC up through the exhaust all the way to the roof. And then they used a polypropylene kit that caps off the top of the chimney and then draws air in through this space, the annular space around the exhaust vent. And unfortunately, it didn't work out so well in this case. Old chimneys can be a tremendously bad source of contaminants. Whatever's in the old flue gases that sort of stuck to the chimney walls over the years gets sucked into the new boiler. In this particular instance, this was a 2-month-old boiler. And within 2 months, what had happened was it had just absolutely become completely solid with rust inside. And this was from contamination from that old chimney space. So it certainly can be very dramatic and very quick. And this boiler was effectively destroyed in a couple of months and required heat exchange. So corrosion in condensing boilers is going to take a number of forms. You're going to get crevice corrosion, you're going to get cracking corrosion, stress corrosion. One of the more common kinds, though, is pitting corrosion. And basically, pitting corrosion is kind of what it sounds like. You get pits in the stainless steel. What causes that is stainless steel is only stainless because it has a passive layer of chrome oxide. So stainless is a mixture of typically nickel, iron, chrome, a little bit of carbon, some other metals. What happens is the chrome creates a stable layer of oxide. So a bit like aluminum, chromium forms an oxide layer that's pretty stable, not much bugs it. One of the things that does tend to bug it, though, is chlorides, and they strip off some of this passive layer. And what that allows is the action of whatever chemical is there to interact with the iron that's in the stainless steel. And that iron gets leached out of the system, and you end up with a pit. Now, this will happen mostly in anaerobic situations where there's not as much oxygen available as we might like. And of course, that's exactly what you get inside a combustion chamber, because when the burner is operating, there's not much oxygen there, but the leftover chlorides will interact with the iron and effectively create a pit that will eat a hole through your heat exchanger eventually and cause you to have a premature failure. Now, those pits are going to evidence themselves in the form of little black or brown rust nodules that you're going to find in the bottom of the combustion chamber. And if you find a whole bunch of these in your boiler, you should be aware that what you're looking at is the boiler itself. It's dissolving, so something's attacking the stainless. The iron in the stainless steel is dissolving or rusting, and it forms these nodules. They look a bit like coffee grinds or instant coffee, and they fall off when they get large enough into the bottom of the combustion chamber, and eventually enough iron is leached out of the stainless that it can't retain water anymore, and you get a leak. So if you're seeing tons and tons and tons of these coffee grinds in your boilers, they're going to have a pretty short life. They're going to have a very high maintenance requirement, obviously, and they probably won't last particularly long. So you'd want to find out where the boiler is getting its air from. Is there something you can do to eliminate the source of contamination? Can you move the intake to a different location, put it on a roof, move the dryer vent, whatever it is? If you don't do something, eventually it's going to kill the boiler.